All right, so now that we've talked about exponents, we want to talk about polynomials. What does it mean to be a polynomial? And a polynomial is the sum of terms. We talked about terms before at the beginning of the semester, a term being the product of a number or a constant and variables raised to non-negative powers. So a polynomial is a collection of these guys. We're just adding these guys. You know, adding and subtracting, because remember, subtraction is a form of addition anyway. So I could say something like this: x squared plus 6x plus 7. That's an example of a polynomial. It's got how many terms in it? It's got 3 terms, and that's a polynomial. I know. Riveting. Are you excited? Well, when we talk about polynomials, a lot of times we talk about the degree of a polynomial and the degree of its terms. So the degree of a term, is the sum of the exponents. It's the sum of the exponents of the variable factors. The degree of a term is the sum of the exponents of the variable factors. Okay. Now what I'm going to do is I'm going to give you an example of a larger polynomial, and we're going to discuss how many terms it has, what is the degree of the term, and also what is the degree of the polynomial. So let's try this. 10x to the 11th minus 7x squared y to the 5th plus 8xy to the 7th minus 120x to the 4th plus x y squared a minus 3. How many terms are in this polynomial? I've got 6 terms. Okay. Now what I want us to do is I want us to identify the degree of each term. Okay. So if I look here at this first guy, I want to find out what is his degree. Now the degree is the sum of the exponents of the variable factors. So the only variable factor I have here is x. So what would you think the degree of the term is here? No, it's just going to be 11. The degree, or the strength of a term, lies in the variable components. It doesn't matter what the coefficient is. It's all about the exponents. How many factors of variables do we have here? If you strung all these out, how many x's would you have? 11. You have 11. So that means its strength is going to be 11, so to speak. So when you get to larger and larger values for x, this guy gets to be really huge because of the exponent of 11. What about this next term? What is his degree? 7. His degree is 7. How'd you come up with 7?
2 and 5.
2 and 5. If you wrote all those exponent factors out, you'd have 7 of those guys, right? Does this factor of negative 7 ever change? Does he vary? No, because he's a constant factor, right? But the x's and the y's can vary, and they vary on the order of 7. Okay? You have a degree of 7. What's the degree of this next guy?
8.
Why 8?
Whoa,
Whoa, x is 1?
No, x has an exponent.
X has an exponent of 1. Right. And y has an exponent of 7, so when you add those guys, you get 8. Okay? So between these two terms right here, which one's stronger? The one that has a degree of 8, right? Out of all 3 of these, which one is the strongest? The first one that has a degree of 11, right? Now, when you get to numbers close to 0, he's not as strong as the other ones. But once you go beyond 1 or negative 1, he really takes over. And we'll talk more about that here in just a moment. What's the degree of this guy?
4.
4. What's the degree of this one? This is x to the first and a to the first, so 1 plus 2 plus 1 is 4. What about this constant piece right here? What's his degree? 0? 1. You're saying he has a variable that he can vary. Does he have any variable factors? He has 0 variable factors, so his degree is 0. I never told you 1. Don't
You
get
made
mad.
me think it was.
Well, then you were wrong.
Is this just kind of a way of determining how to rewrite it?
We're not rewriting this. This is just determining the strength of each term. We don't really do a whole lot with that in this class, but in future classes like 0310 and college algebra, you'll look at what this means when you look at a polynomial function. The degree of the function, the degree of the terms, the degree of the polynomial all tie into special things. Okay. So we're talking about the degree. Let's talk about the degree of a polynomial. So we just looked at the degree of each term. The degree of a polynomial is the largest degree of its terms. The degree of a polynomial is the largest degree of its terms. So what would you say about this guy? So from our last example, what was its degree?
11.
Right, the degree is 11. That's the strongest one. And what that means for us is that as x gets really, really large, he's going to be dominated by this guy right here, this leadoff guy. That's the one that's going to control how things move. Questions about that?